Right, so today we are going to talk about the absorption and emission spectra, which is one of the topics that people find quite tricky, and I actually do as well. So back then I was like, what the heck is going on? But anyways, I hope that after this video you'll find it useful, that you understand a bit more, and hope that you'll feel better. Yeah, so let's start straight away. The first thing that I would like you to know is the two equations that we always use. C equals F lambda and E equals HF. The C is the speed of light. The F is the frequency, and the lambda is the wavelength. The E here is the energy value, or we could later say is the energy difference, which will make a bit more sense later. And the H here is the Planck's constant. The F here is the same as the F in this equation here, which also represents the frequency. So as you can know, you could actually merge these two equations together, and you could get something like E equals ht over lambda. If you have the value for the wavelength, you could somehow find the energy value involved. From now, it doesn't really make sense. What energy are you talking about? What wavelength are you talking about? Hopefully, it's going to make sense after more explanations, yeah? Electrons, actually, they are quite interesting because this is out of topic, yeah? But we often say that electrons, they have a wave-particle duality. So electrons can exist as a wave or as a particle. And that's why electrons, they do have a wavelength, but they do also have a set value amount of energy, which is a particle, yeah? But, yeah, so now we're going to talk about the absorption spectra. So I'll say what I see. Well, absorption spectra here, we've got a colored background and we've got black lines. These black lines, they are discrete. They don't overlap each other and they have their own position. So what do these black lines represent? They actually correspond to the energy absorbed by the electron from a lower energy level to a higher energy level. So they are the energy difference from lower energy level to higher energy level, yeah? And the emission spectra is the other way around. There's a black background with colored lines. And what do these colored lines mean? Well, they are the lines that is the energy difference of the electrons from a higher energy level to a lower energy level. Well, this is all you need to know. Like, memorize it as fact. Now I'm going to explain what it actually means. From A-level chemistry, you know that electron shells are bullshit and they're rubbish. We often say energy level from now on, yeah? But we're going to still use the basic model of an atom and electron. So let's say that we have a hydrogen atom. It's in the ground state. It is in the n equals 1 energy level, or the first shell, yeah? But we also know that there are actually imaginary and theoretical energy levels that hydrogen have. So the hydrogen, actually, if you give the enough amount of energy, and it must be absolute, I will explain why later. If you give in the exact amount of energy, the electron can actually jump and be excited to a higher energy level. So let's say n equals 126. It doesn't matter what energy level there is, because there are infinite amount of energy levels, theoretically speaking. So the absorption spectra is literally what this means. Well, in this context, it's not really n equals 1, but let's say that we need to understand this concept. It is the energy that you give in that causes the electron to excite and jump up. This is like a weird phenomenon that nature gave it to us and we need to understand. And similarly, for emission spectra, it is when the electrons are excited and they try to jump back to the lower energy level. Because we know that in chemistry, the higher energy level that you are, so the more energy that you have, the less stable you are. So electrons, they prefer themselves to be in a lower energy level, and hence when they're excited, they actually drop back to a lower energy level. And when they do so, they actually emit some energy out. And this is the energy emitted as a photon, or you can say EM radiation. Right, so this is like the reason and the background for atomic spectra, yeah? And now I would like to explain a bit more and add a bit more on that. So there are certain energy levels, well, actually 1, 2, 3, n equals 1, n equals 2, and n equals 3, that we need to know and be careful of. So whenever you have an unknown energy level dropping down to n equals 1, we call that the Lyman series. When you have some energy level dropping to the second energy level, we call that the Balmer series. And some energy level dropping to third energy level, this is the Paschen series. But we don't really care about this one because it doesn't make any significance. But for the second one, for the Balmer series, is actually quite important because wherever the energy level drops to n equals 2, it is in the visible light region, which is why we can see this spectrum here. So all the lines here actually drops to n equals 2. Well, in the absorption, it would be from n equals 2 up to some energy level. But in emission, it's some energy level dropping down to n equals 2 energy level. I hope it makes sense from now. It might seem still confusing for a bit, but just listen for a few more times and perhaps you'll understand, yeah? Yes, so there are two main things. What I'm going to say is it's quite easy to understand, but it's quite hard to explain. So in exams, often, I'll rub that off first. Often in exams, they are going to ask you two things. One, why the lines are discrete. And two, as frequency increases, the lines converge. And these are the two main points that people get stuck on. So I'll try and explain it. So let's start on the first one. Lines being discrete. So we know that the lines here actually represents the energy level difference. So from n equals some energy level 1 to 6 down to n equals 2. So I'll actually like to think them as conclusions and findings rather than thinking of them as why. I hope that makes sense in some way. But yeah, so if you think about it, all these phenomenon are done by experiments. So let's say that a mad scientist, he was doing experiments on hydrogen atom and he was wondering how the electrons move and jump and, those things. And he found out that the energy involved in transition is absolute. So he found out that, let's say, from n equals 5 down to n equals 2, it must be in a set value. So I know there are values here, but let's say I'll make one up. 100. From 5 to 2, it must be 100. And similarly, if you go from 2 to 5, it must also be 100. And that's what explains why the lines are in the same position for emission and absorption spectra. Because they require the same amount of energy to be excited or to drop back. So from that, because he found out that the energy involved in the transition must be absolute, he then concluded that the energy level itself must be, the energy level existing must be absolute and in a set value. Because we all know that these energy levels, they are actually energy, yeah? So if you are, so let's say that if you have 100 kilojoules of energy, you're in n equals 1. If you have 200 kilojoules of energy, you're in n equals 2 energy level. This is what energy level means, yeah? And yeah, because he found out that the energy involved in the transition is absolute, he concluded that the energy level existing must be absolute and in a set value, and hence why it is the lines that are being discrete. Well, perhaps it doesn't make sense. Let's think of a metaphor here. You are in a building, yeah? And you are, these are the windows, yeah? And you are trying to get from n equals 1, so the first floor, to the second floor. The requirement is you need to walk 10 steps from the first floor to second floor. And you need to walk from second floor to third floor 10 steps down. If you walk 11 steps, you are not in the second floor and you're in somewhere else, yeah? There is no such thing as 1.1 floor, 1.2 floor. It doesn't work. It must be only the first floor or the second floor or the third floor, because the second floor is where the canteen is. The first floor is where the toilet is, etc., etc. This exactly is the same in the atomic world, in electrons. If you're in n equals 5, if you're in n equals 5 energy level, it must be that value. If you don't hit that value, you're not going to reach there. So that's what I mean by they exist in a set value. And once again, we know that the lines here, they represent the energy level difference. And that's why they are discrete. I really hope that it makes sense. But if you don't, try to have a listen again, and I hope it'll make sense in some way. So what it means is that if we are looking at the emission spectra for this line, it must be n equals something. So let's say that it's n equals 6 down to n equals 2. This line, it must be n equals 8 down to n equals 2. It can't be n equals 9.1. No, it's n equals 8, which I made it up myself, to n equals 2. And it must be n equals 2 because it's in the Balmer series, and where we can see it because it's in the visible light region. So this is the first point, why the lines are discrete. Now we move on to the second point. At higher frequency, the lines converge. Now let's go back to this diagram here, the spectral diagram. We know that wavelength and frequency, they're inversely proportional. So as wavelength increase, frequency must decrease, yeah? So as we can see here from these values, the wavelength increase here. And that means the frequency increases or as you go left. And you can actually see this. You can see the gap here. It's getting smaller and smaller and smaller and smaller and smaller. And you can see from this diagram again, you can see the gap between 6 and 5 is that, and 3 and 2 is that, and 2 and 1 is that. So what is the explanation for that? Well, again, I'll try to think it of as a conclusion. So the scientist that we were saying just now, doing these experiments, he found out that the energy level difference, this time is the energy level difference, as you increase the frequency, is decreasing. So the energy level decreases as frequency increases. So what I mean by that is, let's say that you're in n equals 120. You go down to n equals 119. This value is actually similar to n equals 118 down to n equals 117. But when you're comparing this value with n equals 2 down to n equals 1, like there's a huge gap, man. There's a huge gap. So, yeah, so why is that? We actually don't know. This is what the scientists found out, and this is nature. And yeah, this is the point that I'm trying to find out. That I'm trying to explain. you can see that the gap is getting smaller and smaller and smaller and smaller. And when n is infinity, which is a theoretical energy level, the lines actually converge together. So they merge together and they make a continuous thick band, which you can no longer distinguish between which energy level to which energy level. Well, this is the time when the scientist then concluded that the lines converge at a higher frequency, because he know that from the values that he have from doing the experiment, that the energy level difference, the energy difference decreases as the energy level difference decreases. So yet again, I'll explain this again, oh God, is let's say that you are in n equals 120 down to n equals 119. This energy level is so small. So the energy value difference is tiny comparing to this, which is huge. And this is what it means. As you increase the energy level, the energy difference between consecutive energy levels, it's getting smaller and smaller and smaller and smaller and smaller. And this is a finding. And as we know again that the lines here, they actually represent the energy level difference. So as the energy level difference increases, the energy value difference decreases. And we know from E equals HF, if the change in energy decreases, the frequency must decrease. Does it make sense? Nah. Well, what I'm trying to get here is, as the frequency increase, the energy level increase, yeah? And so that's why at higher energy level, it's more to the left in this context. So, I apologize, my brother was talking, but we'll move on. So, yeah, back on topic, and that's why at high frequency the lines converge. The last thing that I would like to add is people are also struggling of, so let's say that we now have these two lines here. So which one is from a higher energy level and which one is from a lower energy level? Because we all know that it's going down to n equals 2. But which one is higher, which one is lower? Well, the answer lies with this this equation that we have here. So as we know that as frequency increases, the energy level increases, yeah? And the frequency goes increasing on the left side. So that means it must be this that is in higher energy levels. So let's say that this is energy level 8 and this is energy level 6 going down. Because they have the same endpoint, n equals 2. If you have a high energy level going down to a lower energy level, the difference is larger, yeah? And if you have a lower energy level going down to n equals 2, the energy difference in that is lower. And that's why the frequency increases and the energy level increases on the left in this diagram. Well, I hope it makes sense in this way, and I understand that hearing this and listening this in the first time might not make a lot of sense, but I hope after sort of like maybe listen to this once a week, or listen to this more, and perhaps you'll understand, perhaps it clicks at one point, because this is what happened to me. But I hope the video has been useful, and peace out. I'll make more videos on chemistry. Bye bye.